We're going to take a look at problem 348. It says the height in centimeters of a piston is given by the equation h of t is equal to 12 cosine of pi over 3t plus 8, where t represents the number of seconds given, the number of seconds since the measurements began. So the measurements began at some point, so it's somewhere in the curve, and we'll continue from there. It says determine the average rate of change. That's another word for slope in the centimeters per second. So the average rate of change between centimeters per second. Now centimeters is the height and seconds is the time, so that's pretty much saying y over x, or slope, of the piston's height in the interval 1 to 2. All right, so it says, so that's the first part of this question. We'll talk about the second part in a minute. So firstly, a piston, if you're not sure what that is, would be maybe a cylinder of some sort, and then it has like another cylinder inside, and some sort of a stick or a metal arm would pull it up and down. So it would create force and push up and down into this other cylinder to maybe generate electricity of some sort. But the point is, it starts down and goes up and then comes back down again, or vice versa. So that would mean its height would be modeled with a cosine curve. So in this case, it's a regular cosine curve, so it's going to start off at the top, then it's going to go down and come back to the top. So in other words, it's going to start out of the container, push down, and come back up. The midline is 8. We could see that in the equation here. Next, we can see the amplitude is 12, so that means the maximum is 20, so that's 20, this is 8, and down at the bottom would have to be 12 units below 8. Let me actually just move this over. Okay, so so it's 20, that's 8, and down at the bottom would be negative 4. So that means this piston probably pushes through the container. So the question says, what is the average rate of change? Oh, we don't know what the period is at the moment. I don't think we need to know for this question, but we can find it using the formula. It says find the average rate of change. So the average rate of change, we need to know 2 points. We're going to make a table of values here. So the table of values is going to be t and h of t for this problem. The t values are between 1 and 2 seconds. So that's going to be somewhere on this graph. So let's say that was from here to here, just as an estimate. Let's say that was 1 second, and let's say this was 2 seconds. We want to know the slope between those 2 points. Okay, so this is 1 something and 2 something, and we need to figure out what those are. So we're going to use a calculator to do this. So I'm just going to pull up my calculator app, and you should be able to see that now. I'm going to fill in the equation for this problem exactly as written. Now, in any problem that uses pi in it, or for graphing purposes, we're going to be using radian mode. So this is where radian mode comes in. Because in degree mode, 360 is normally how long it takes for a curve to complete its full cycle, but on radian mode, it does it at 3.14, or 6.28 at 2 pi on a regular curve. So we're going to enter the equation to the y equals menu. So I'm going to enter 12 cosine of pi, pi divided by 3 times, I'm going to close that, I'm going to put the variable next to pi, so I'm going to type second x, whoops, I'm just going to type the x key, divided by 3. So this should be that equation so far, plus 8. So if I look at the graph of this equation, oh, you can see it, we're a little bit zoomed out on my graph here. So, all right, the maximum value appears to be 20, the minimum value appears to be negative 4. It completes its cycle, it starts at the 20 and it ends at the 20 again, and it's somewhere before 10, that's like 2 pi, or the 1/3 would probably make it take longer. But this is our curve, and the slope is going to be occurring between 1 and, well, let me do the trace feature maybe. or it's going to be occurring between, okay, so can I play with this button? Here. All right, I'm going to zoom in. Trying to zoom in here. It's the first time I've actually used this. Okay, so this is my point. I'm going to go over to 1. So this is an x value of 1. It's around 13. We're actually going to use our table to find this in a minute. And then 2 is going to be something like 1.4. So I'm going to close this. I'm going to go back to the table. So I'm going to press second and graph to see the table of values. And I see 1 gives us 14, and 2 gives us 2. So we're just going to find the slope using the slope formula, which everyone should know. It's m equals y2 minus y1 over x2 minus x1. So by plugging in the numbers we have in this problem, I don't think we need this anymore, at least not for now. The second y value is 2. The first y value is 14. The second x value is 2, and the first x value is 1. So we're going to get the slope is equal to negative 12 over 2, or negative 6. Now let's take a look at the second part of this problem. So that's the average rate of change in the piston's height in that time period. The next question, I'm going to change color here. So I meant to use red, but I used it already. At what values of t to the nearest tenth of a second does h of t equal 0? In other words, when will the y value equal 0? Between the seconds 1 and 5. So let's go back to our calculator for a moment. I'm going to look at the graph just to kind of show you what we're looking at. So it says between 1 and 5, which we can see is here. All right, so from 1 to 5, so it's from this point over here to here. It says, where does the graph touch 0? So it looks like it should be somewhere between 3 and 4, closer to 4, and somewhere between 2 and 3, but closer to 2. What are those values? Now, we're going to go to the calculate feature of our calculator. I'm not sure I have it on this calculator. Calculate. Not sure. I might have to go back into the table here and press the calculate button. Oh no, it's not a feature I could use here. But it's going to be somewhere over here. So if I were to scroll closer, it's approximately 2.19. So for this, it would be the h of t will equal 0 for when t is equal to 2.2, and let me just scroll this over. Where did I lose my point? Here, approximately 3.8. And there are similar ways to do this with a regular calculator, which I don't have on hand for this question at the moment.